afternoon from where you are. Today I want us to talk about trigonometry, and when we talk about trigonometry, we are only going to deal with the right angled triangle. Like when I'm talking about right angled triangle, these ones are triangle that has got one of the angles has got 90 degrees. So like for example, when you check this triangle that I've just drawn, it is a 90 degrees triangle. So this one is a right angle triangle. That is the name. So the name is a right angle, a right angle triangle, a right angle triangle. So the part that I'm going to talk about trigonometry always deals with the right angled triangle. So just stick in as you're going to learn several things here. So we all know that when you are trying to find, we all know that this side is the hypotenuse side. Hypotenuse side. So that is the distance from this point to this point is the hypotenuse side. Then you also know that there is this point, so I want us to name it point A, B, so distance from A to B to C, distance from A to B to C. So distance between A to B is the adjacent, that is A to B is adjacent. And we have C to A or A to C, so we call it the opposite. So this is the opposite side of the triangle. So the triangle, we have the adjacent side, that is the distance from A to B, and the hypotenuse side, that is the distance from C to B or BC. Then we have the opposite side, that is the distance from AC or CA. So in short, we always have an angle here, and that angle we refer to it angle theta. So that is angle theta. So angle theta can be cos theta, sin theta, tan theta. Like so, from A to B, we've said it is an adjacent. Then A to C or C to A, it is the opposite side of this triangle. Then C to B or B to C is the hypotenuse side of this triangle. So in short, we can give out the formula of finding the theta, that is this angle here. So first one, we usually have the sine of that angle theta. Then we also have the tan. So you can also be asked to find the tan of this angle here. Then apart from that tan, we can also be asked to find the cos theta. Now we can always find them, the sine, the tan, and the cos by using various formulas that they have. Let's start with the sine. How do we find the formula for the sine? The sine theta is always given by the opposite all over the hypotenuse side. That is, when you want to find this angle, you use the opposite side. So the opposite side is AC. What's 2 plus 7? That is 9. Lily B, what are you referring to? 2 plus 7 is 9. The one that I've drawn here is a right angle triangle, and we are just talking about trigonometry as a topic, whereby trigonometry usually deals with the right angles. So I've written here, I've just given them the numbers, like here AB, the distance from AB to BC, again back to CA, whereby I've said that the distance from B to C or CB is usually the hypotenuse side. They say that is slanting. Slay Queen, you are asking what's 5 minus 7? That is 5 minus 7 is minus 2. Minus 2. Slay Queen. So I've said that BC is the hypotenuse side. AB is the adjacent side and CA or AC is the opposite side. So we are saying that when you're finding the sine of theta, you're going to take the opposite side, and the opposite side is this, all over the hypotenuse side. And the hypotenuse side is BC or CA. Okay, let's now learn the formula for finding the tan theta. So that tan theta, we shall have the opposite side, that is the opposite all over the adjacent, opposite over the adjacent. How? This is the opposite side. Maybe if opposite side we are given as 9, we shall have 9 all over the adjacent side, which is this side. Benyan is saying modes 21, mode 7. Referring to mode, I'm not getting mode. Maybe if you can reframe the question again, Benyan. Okay, so let's now move to cos theta. Cos theta is now this formula is just given by the adjacent over the hypotenuse. Adjacent over the hypotenuse. Yeah, Philippa have helped in answering that question. 2 plus 7 is 9. I've also talked about 2 plus 7 is 9. Thank you. Yeah, Philippa, thank you so much. 5 subtract from 7 is minus 2. I've also given that response. Thanks a lot. Okay, so we can proceed with the trigonometry. So, cos theta, and make sure you subscribe to the channel, please, and you like the live. You know, it's you're supposed to like the live, please, and you subscribe. Thank you. Okay, so cos theta is given by adjacent over hypotenuse. Now, so all in all, after you've mastered all these formulas for the trigonometry, the next thing that you shall do, you shall ask you can be asked to find some of the angles of this triangle. Given one of the side, then one of the angle, you can be asked to find maybe this side, the opposite side of the or the adjacent side of the hypotenuse. And I've given that example. Now we can now try an example. We can now try an example, and this one is the example. Here, I know now you've mastered that formula. Let me now put my example here. So, just pardon me, I just want to be fast, no ruler. So, given that there's an angle here, and this one is angle A, then there's 9 here, then this is 9, then this is 15. Okay, this one is 9, 15, then there's an angle here. So the question now say that given this triangle below, find the sine. This triangle, find the sine. Okay, also find the cosine, and also find the tan. So this one is the triangle. So given that one, find the cosine, find the tan, and find the cosine. So how do you work out this? Now we are asked to find the sine. Now sine, we've said that for us to get the sine is equals to, from this formula here, sine is equals to opposite over hypotenuse. So we shall have sine is equals to opposite over hypotenuse, right? Now, so our opposite side shall be 9, because 9 is the opposite. You can check 9 is the opposite. So we shall have 9, and this 9 we shall divide it by the hypotenuse side, which is 15. 9 out of 15. So, and what is the answer? 9 out of 15? We shall have 0.6. We shall have 0.6. So, meaning that sine meaning that the sine, given that it is opposite over hypotenuse, we have the sine that is 0.6, because the opposite is 9, then the hypotenuse is 15. that side that is slanting. Okay, so let's now move to the next bit whereby you are asked to calculate the tan. The tan, I think, yeah, we are told, no, the cos. Yes, cos, then tan. So this one, cos. How do we calculate cos? From this formula, right? Cos is equals to adjacent over hypotenuse. Exactly. So cos, we shall have adjacent over HYP, hypotenuse. So that is to mean adjacent. What do you have from the side of the adjacent? Okay, adjacent side is this side. You know, this side we've not been given from this point to this point, this distance to this distance. We've only been given the one from here to here and from here to here. Now, so for us to get the adjacent, we are going to take the hypotenuse. We shall take the hypotenuse. Okay, that is hypotenuse, subtract from the opposite. Hypotenuse subtract from the opposite. So we shall have the hypotenuse squared, subtract them from the opposite squared. That is what we shall have. Now, so what is the hypotenuse? Hypotenuse is 9. So then we shall have 9 squared. Exactly, we shall have 9 squared. And also we shall have opposite is 15. So in short, we shall have, okay, we shall have 15 squared, subtract from 9 squared. So what is 15 squared? Is 225, subtract from 9 squared is 81. Okay, 9 squared is 81. So when we work out all those things, all that answer, we shall have the answer as 12. We shall have the answer as 12. Because once you get this, you find the square root. So you shall get the answer as 12. So when you get the answer as 12, now, meaning that our adjacent side shall be 12. So our adjacent side shall be 12. Now from there we can now find the cos now. So we've said that the cos is equals to adjacent over hypotenuse. So our cos shall be 12 all over the hypotenuse is 15. Is 15. And the answer is, what's the answer? The answer is 0.8. 0.8. So our cosine is 0.8. It is the adjacent over the hypotenuse. Now, where is the adjacent? Adjacent is here. The distance from, allow me to name them, A, B, C. So, our adjacent is AB, which is 12. And our hypotenuse is BC, which is 15. But initially we were not given this side here, the AB. That's why we took the Pythagoras theorem, where we had 15 squared subtract from 9 squared, and that is what we've done here. And the answer is 12. Then we got the tan, that is 0.8. Okay, so this one that is remaining, we've not found the one for the tan. Exactly, tan. This one here, the tan. So allow me to work it out here. So when you are asked to find the tan, so tan is equals to, we've worked it out, tan theta is equals to opposite over adjacent. So you just have opposite over adjacent for you to work the tan. So the opposite is 9. The opposite is 9. This 9 here is the opposite. And the adjacent is 15. So we shall have 9 out of 15. And the answer is 0.75. 0.75. So that is how we work them out. That is how we work them out. I want us to move to the next. So before I move to the next example, please kindly subscribe to this channel, because it is one of the #1 channel that gives you everything to do with the maths. Before I move to the next, Even if I move to the next, I want us to grasp this content first. I've said that trigonometry, we use trigonometry in working out the right angle triangles mostly. And the right angle triangles, when you have them, we usually have the adjacent side. So the adjacent side is what we refer to the base side. That is AB adjacent. Then the opposite side usually refers to the height. Then the hypotenuse side usually refers to the slanting side, the hypotenuse side. So when working out this sine theta, this one here, this one is an angle. Sine theta is opposite over hypotenuse. Opposite is this one. Hypotenuse is the slanting side. Opposite side is also refers to as the height, but don't write here as the height. Okay, the tan theta is opposite over adjacent. So tan theta is the one that you are having here. Opposite side is this, adjacent side is this. Then cos theta adjacent over hypotenuse. So once you master all that, now that is why now we've done an example to explain what we are talking about. And this is the old example, like sin theta is opposite over hypotenuse. Opposite is 9 over 15, and the answer is sin theta is 0.6. 0.6. I want us to move to the next thing, because now we've mastered that. Okay. The question says, given that cos 40 degrees is equals to cos 40 degrees is equals to 40 over 41. Find the value of tan. Find the value. Find the value of tan 40 degrees. Find the value of tan 40 degrees and sine 40 degrees and sine 40 degrees. Okay, so the question says cos 40 degrees is equals to 40 over 41. Find the value of tan 40 degrees and sine 40 degrees. So how do you go about this? Now, here is the solution. Let's now work it out, the solution. So, the solution, we shall talk about the cosine of an angle, because we are majorly asked about the cos. So, the cosine of an angle is equals to the formula you knew, opposite over adjacent. It was opposite over adjacent. That's the formula for the cosine, opposite over adjacent. Let us confirm. Cosine rule, we had cosine rule, opposite over adjacent was for the tan, but now the cosine of an angle we shall have, because we have cosine 40, where we've said we have opposite over adjacent. Now, so the opposite is 9. The opposite is 9 out of 40. So now the adjacent side is 40 degrees. Adjacent side is 40 degrees. Because why do we say the adjacent side is 40 degrees? They're saying the value of tan 40 degrees. And formula for tan here is opposite over adjacent. That's why we have the opposite over adjacent there. So from that, from that particular point, we are talking about okay, the adjacent is 40 degrees, right? And the hypotenuse side is 40. Hypotenuse side is 40. It's not 40 but 41. Hypotenuse side is 41 degrees. Okay, so the hypotenuse side from here, when talking about hypotenuse side, we are talking about sine theta, opposite over hypotenuse. Tan theta is opposite over adjacent. So maybe from in our next part, I shall talk more about this other side from here. So from now, I just want you to grasp this content first. Then from there we shall proceed. Maybe some 2 hours from now. Thank you so much.